Welcome to the Lifespan Podcast, where we discuss the science of aging and how to be healthier at any stage of life. I'm David Sinclair. I'm a professor of genetics at Harvard Medical School, and I'm co-director of the Paul F. Glenn Center for Biology of Aging Research. This podcast series is about why we age and why we may not have to, things you can do today and going forward to increase your wellness and to potentially live a much longer, healthier life. We've talked about the biology of aging. We've talked about things that you can do at home, preferably under the supervision of your doctor. And today we're going to talk about things that you definitely will be talking to and requiring a doctor's supervision to do, and even things that your doctor is unable to do, but potentially in the future may be able to. I'm joined today by my co-host and my co-author, the lovely Matthew LaPlante. We are definitely doing it. Today we're doing a deep dive into some, somewhat controversial stuff.
This is a scary episode.
Well, I don't know if it's scary, but we have to do a disclaimer. I think we have to say that what we're going to talk about today, a lot of it isn't approved by the FDA, but maybe in the future. And some things that were available until recently and were banned by the FDA and are currently available only offshore.
And just as was the case when we had the conversation about drugs and supplements, and maybe even more so in this case, there's a lot of misinformation out there about a lot of things that we're going to be talking about today, these potential avenues for addressing longevity. We're going to try to cut through that, but we are not doctors of the physician type.
That's right. I'm a PhD in genetics. I'm not a physician. And so the things we've talked about in this series should always be done with the supervision and advice from your physician.
Yeah, podcast is no substitute for a physician.
That's right. But I'm a scientist. I can read the scientific literature, can distill that down. You're a science communicator, and we're here to be able to distill the wealth of information that's out there and distinguish what's fact from fiction and give people, a starting point as to really how do they figure out what's best for their wellness and what's actual complete bull out there.
And so today we're going to be talking about stem cell therapy, peptides, exosomes, testosterone, growth hormone, and then we're going to spend a little time talking about one of your favorite subjects, epigenetic reprogramming. All right, let's dive in by starting today with testosterone. Super popular subject, lots and lots of growth in testosterone replacement right now because of the fact that testosterone decreases as we age, and that's disconcerting to a lot of people.
Well, for sure. After the age of 30 to 40, we lose about 1% of our testosterone levels, men and women. It's important for both sexes. The market has grown. So TRT, or testosterone replacement therapy, has grown from a few $100 million 10 years ago to multi-billion dollars now. And it's widely used not just to supplement for sexual dysfunction, which is a common side effect of low testosterone, but for other things that include mental health, building muscle, overall fitness, vitality.
And people swear by this. I mean, a lot of people, they do this. They say they feel younger. They say they feel more vigorous. They want to have sex again. They want to have sex all the time. There's an important distinction to make here, though, which is just because you feel younger does not necessarily mean you are reversing your biological aging.
Right. Let's make a clear distinction. We've talked about adversity mimetics. And in the last episode, we talked about the supplements and the kind of things that you can do in your life to mimic that. We want our bodies to be in a state of fear, that times are tough and they need to hunker down and survive. There are other types of things that we're going to talk about, which are abundance mimetics. Testosterone is one. We're going to get to growth hormone as well. These tell the body that times are good to build your muscle, to reproduce, go forth, multiply.
And that's what testosterone is doing. When we get testosterone replacement therapy, we are putting a substance back into our body that has been reduced, but which signals our body that times are good enough. It's okay to build muscle. It's okay to run around chasing woolly mammoths.
Yeah, well,
chasing the cave women around.
Exactly. Yes, that for sure. And that benefited our ancestors very well, but it didn't help them long term. What we now appreciate is the body has cycles of want and need and adversity, which is good for the long-term health of the body, and times where things are abundant, times to grow, reproduce, which are great short-term, but probably not great for long-term health and longevity either.
Okay, so let's talk about what actually happens when our testosterone lowers and what happens, importantly, when we put it back. Because this is helping a lot of people with a lot of problems that are coincidental with aging?
Oh, for sure. There have been a lot of studies, millions of dollars and many thousands of people treated with TRT, as it's called. Shelley Basin, who's a colleague of mine at Harvard, has done a lot of these studies. And he's found some improvements, short-term improvements. So, of course, improvements in libido, but also he shows a dose-dependent increase in skeletal muscle mass. So you get bigger muscles. You got more power. You can climb stairs. You can walk further in 6 minutes. Improves aerobic capacity. These are all good things that he sees. But actually, it's not all good news. There are some side effects and may actually impact longevity. So some of the risks of TRT, there's worse sleep apnea. You can actually get larger breasts. Little known fact is your testosterone can be turned into estrogen, which is a risk for men particularly. You can have what's called benign prostatic hyperplasia, so a bigger prostate, need to go to the bathroom at night. Shrinking testicles, not something I think many of us would want. And increasing red blood cell protection, which could lead to blood clots.
And if you're already predisposed to prostate cancer, you have cancerous growth already, this could actually aggravate the tumors.
Yes. And actually, the opposite is true. If you look at the history of eunuchs, they live longer. And so it may actually be that supplementing with testosterone is not conducive to longer life.
Okay. So this is an important principle here, and we're going to come back to this a couple of times on this episode, which is just because something makes you feel good today, and just because it might even be medically beneficial to you today, that does not necessarily mean it is addressing the causes of biological aging. It may be fixing something that you have a problem with. It may be improving even your quality of life right now. Long term, that's not the same thing as reducing or eliminating biological aging.
Yeah, let's go back to the main concepts here today, which are that adversity mimetics are great, things that mimic lack of food and a lot of exercise, but these abundance mimetics are probably a problem long term, even though they make you feel great short term.
Okay, and that's sort of giving away the punchline for HGH, but we need to talk about HGH as well. Human growth hormone, also something that is really popular right now. People supplementing with human growth hormone to address things like decreased exercise capacity, decreased bone density, decreased muscle mass, and increased body fat. This works, right? For those things, this HGH is helpful.
Well, no question. Short term, you'll feel better, you'll grow muscle, you'll have less fat on growth hormone therapy. The science says that this may not be good for long-term health and wellness. Going back to the original studies of Cynthia Kenyon, which we talked about in episode 1, those mutant worms had low levels of growth hormone and insulin-like growth hormone signaling.
And they live longer.
Twice as long. And this has been reproduced also in mice and even in humans. There are the Laron dwarfs we were talking about earlier. These are smaller people that have low levels of growth hormone, or actually IGF-1, one of the versions of this pathway. They are relatively resistant against cancer and heart disease and may even live longer. Conversely, if you're supplementing with growth hormone long-term, the chance is that you're having the opposite, that you feel great, but long-term you might have even greater risk of cancer and heart disease.
And you know people who are on HGH for various reasons. One of the immediate side effects, even before we get to sort of like the longevity implications, is sore joints, carpal tunnel syndrome.
Right. This is the kind of thing that does happen. Now, I just want to be clear. There are some benefits to bringing the levels back up to normal, okay? But going too high, which a lot of people do if they want additional benefits, that's where I think the main risk comes from.
Another risk immediate is increased insulin resistance.
That's true. We get high levels of blood sugar. We get high cholesterol, carpal tunnel, edema, so buildup of fluid, joint pain.
Okay, so soreness in your joints, insulin resistance. Another one is an increase in the likelihood of type 2 diabetes because of that insulin resistance. All of this actually kind of sounds like symptoms of aging.
Right. And that's the risk. The animal studies are telling us that growth hormone will tell your body that times are good, abundance mimetic, and that's not good for long-term effects of health. And probably what's going on is some acceleration of aging.
Okay, but this isn't to say, again, I think this really, we don't want to say human growth hormone is bad, testosterone is bad. People need to have a naturally healthy level of these hormones in their bodies.
And there are ways to do that naturally. So for testosterone, you can work out the bigger muscles in your body, and that'll also help with growth hormone. So I work out my thighs and my back particularly, keep those nice and strong. And I've found my natural testosterone levels go up to normal levels with that. So that's a way to do it. With growth hormone, it's all about eating at the right time and sleeping. So if you eat not too close to sleep time and then you rest through the night and have a good night's sleep, that's the best way to improve your growth hormone levels.
And if you're doing all of that and you're still struggling to keep these levels up, that's the time to talk to your doctor about supplementation. But that supplementation needs to be aimed not at hyper increasing the levels of these in your bodies, but just keeping them at that sort of like that natural, healthy level.
Well, exactly. But I would encourage everyone to try it naturally first.
So far, this sort of feels like bad news because these are things that a lot of people have gotten it in their heads might be beneficial to anti-aging. And what you're saying and what the evidence suggests is that there is no anti-aging benefit. There might be a short-term gain, not a long-term anti-aging benefit. But these aren't the only things that are sort of like hot on the market right now. Another thing that's really popular to talk about, really popular to try, where it is legal, is peptide supplementation.
Yeah, so peptides, just like hormones, are made of strings of amino acids, but typically smaller, about 100 amino acids. You can synthesize them on a machine or extract them from tissues, and they're used by cells to communicate between each other. So your brain will put out peptides to signal the body, your liver, and your muscle. And some of these are really good, some are really bad. We don't know what they all do. There are probably 1,000 made by the body. We probably only know about what 20 of them do in great detail.
But what we do know is as a class, they help cells communicate to one another.
Right.
And so just sort of like holistically speaking, it's like, oh, that's really good because in part aging is a loss of cellular communication. And so peptides help increase that cellular communication. Voila, they must be great for aging.
Well, again, it's whether you're an adversity mimetic or an abundance mimetic. That's the difference. And really you have to make a distinction between those two things. One of the best studied peptides of all time is insulin. And clearly that's important if you're deficient in it. We've known this since the 1920s.
We actually have 100 years now. It was in 1921, which was when insulin was first discovered.
Right. Banting and Best in 1921 found they could extract this insulin extract from the pancreas of a dog and inject it into a dog that had diabetes and cure it within hours.
And within months, they were trying this on human beings because that's how things worked back then.
Yeah, and they even won Nobel Prizes quicker. It was only 1 or 2 years afterwards that they won the Nobel Prize for that.
So they went from this works in dogs to let's try this out in a 14-year-old boy to Nobel Prize in the span of like 2 years.
Well, it was worth it because in those days, particularly type 1 diabetics, which is the childhood version of this, the lack of insulin meant that the kids would have to go on a starvation diet, and even then they would die within a year or so. It was horrific. And suddenly people were living for decades. That first patient lived for another 13 years.
And so this set us down the road of studying peptides and their health benefits. And then a really big thing happened in the 60s, which is we figured out how to synthesize peptides.
Right. That was a big deal. And then in 1978, they started to be made using recombinant DNA technology. And that's where we find ourselves today, is that most of these hormones and peptides that are available on the market are made using recombinant DNA technology. Though these very small peptides are unique because you can synthesize them on machine, which makes them very cheap.
Didn't you say like there's like some people have these machines at their homes?
Yeah, I'm aware of some people that have them and they're making them at home and injecting themselves. I don't recommend that. That's currently that's off-label use of drugs, and you don't want to do that. But that gives you an idea how possible it is to make a drug these days, especially these peptides.
Because these are, at this point, so easy to synthesize, and because they're relatively cheap, and because they are relatively non-toxic, there's been lots and lots of clinical studies on the use of peptides.
Right. Thousands of human studies. And it's interesting, why are they so safe? Well, they're not foreign. They're typically already found in the body. And they're small, so they don't typically have an immune reaction, though the risk is not zero.
They metabolize quickly.
They're also metabolized quickly. And so the risk is relatively low. And for that reason, there are a number of doctors who have been okay giving these peptides to patients.
And what we're looking for when we give peptides to people, specifically for the cause of anti-aging, is a boost of regenerative signaling.
Right. So what you're looking for is the ability to recover from damage, increase wound healing, lower blood sugar levels, increase mitochondrial activity. Those are examples or signatures of an adversity mimetic, not an abundance mimetic.
Okay, let's talk about some of these. We have discussed in the past MOTS-C.
Right.
MOTS-C.
MOTS-C, so MOTS-C. That's a really interesting peptide, an unusual class that actually doesn't come from the nucleus, the normal chromosomes that we talk about, but from the mitochondrial DNA in mitochondria. And up until about 10 years ago, we thought that there were only 13 genes encoded in the mitochondrial genome, and there are now about 100 known. And MOTS-C is probably the best characterized of those. There's another one called humanin as well. MOTS-C, when injected into mice, lowers blood sugar levels, increases mitochondrial activity, gives you the signatures of long life, probably promotes life. There's some evidence of that, and has been in humans. In fact, there's a clinical trial that was just released, the results of which showed that it reduces fat in the body and improves fatty liver, which are, again, signatures of potential longevity.
And so your belief at this point is that there are likely peptides that are valuable when it comes to addressing the causes of biological aging, unlike these other things we've talked about today.
Well, almost certainly, but we don't know enough yet to say for sure that these are perfectly safe or will increase lifespan. A lot less is known about these peptides than testosterone or growth hormone.
And to that end, the FDA agrees. They're nervous.
Well, yeah, because they became so popular, typically on the West Coast, LA, there was a real mega trend and still is to try these out. And they have a variety of properties that seem to be beneficial anecdotally, improving memory, muscle mass, lowering inflammation. The FDA looked at this and said, whoa, hold on, we don't know enough. And they sent a letter to a company saying, stop making this. And then that sent shockwaves. This was March of 2020. And so since then, it's been impossible to get some of these peptides in the United States.
Because they've stopped compounding them.
Right. So even though there have been some promising results with peptides, the FDA has said some of these need to be regulated, and many of them now you cannot get in the United States.
So they're still in clinical studies. Researchers are still examining them, but the avenues for getting these in the United States have become more limited. There are still people getting them overseas, compounding them in their own machines at home.
Right. But still, we have to be careful because they're not all perfectly safe. And one of the reasons the FDA was nervous about this and banned many of them is that there are some side effects. It's not just that they can be redness where they're injected, but actually it seems like you can induce arthritis type effects when the immune system recognizes these peptides as foreign. And that would be something you definitely wouldn't want to have, is an immunological reaction.
A lot of these have names that are like Star Wars droids. And so people have heard these, heard of these. They might wonder what they're doing. One that's really popular in conversation right now is BP157.
Yeah, BP157 is one of the more popular ones. It's been used to increase blood flow, lower inflammation, and even regenerate neurons for cognitive ability. But there are lots of others. There's one called SS31, which targets the mitochondria and improves mitochondrial function. Could seem to be good for the heart, maybe for longevity. There's another popular one called GHK copper. It's part of a copper complex. It was first identified in human plasma. Later, it's found in saliva and urine. And it's been used to help wound healing, attract immune cells. It's an antioxidant, stimulates collagen, protects tissues against inflammation, can even be used, apparently, to reduce fine lines, wrinkles, and grow hair again. There's a whole bunch of this.
Is this based on, is this anecdotal evidence? Is this research-based evidence? How do we know these things about these different peptides?
Yeah, most of these come from mouse studies, and then they're anecdotal from studies that clinicians are currently doing. Mm-hmm. But yeah, again, I want to stress that most of these things that we're saying are anecdotal and not yet scientifically validated.
These are some people's experiences, and this is all one of the reasons why there is a pretty significant movement right now, this sort of like Save Peptides movement of people who are contacting the FDA and saying, please make these things more available to us again.
Well, yeah, there's one in particular, thymosin alpha-1, which has been known since the 1970s to be beneficial. It seems to be great, particularly for helping against, fighting bacteria and viral infections. But it was also listed on the banned substances in 2020, and there's a movement to bring it back because with COVID-19, it's thought that it could help. Talking about other ones, some of these work with fat loss, apparently. We've got tesamorelin, CJC 1295 is taken with one called ipamorelin. There's AOD 9604, and the BPC 157, again, can be good for weight loss, apparently. One of the other ones I mentioned, humanin, is again one of those mitochondrial-derived peptides like MOTS-c. And in mice, at least, it's been shown to help against type 2 diabetes, high blood sugar, cardiovascular disease, and even help with neurodegenerative diseases like Alzheimer's. But in humans, it's not clear if that's true. Pineolon is a really interesting one. It's actually an active peptide complex, and it's been thought to treat memory, attention deficits, brain injury, stroke, chronic fatigue, etc. But again, early days, we don't know for sure if this is actually true in humans. And then finally, we should just mention there are others that are being used to combat fatigue and also boost the immune system. They go by names like dihexa, cerebrolysine, Semax, Celenc, or even BPC 157 is used with Semax and cerebrolysine together. Again, these are all pretty much experimental. They've been shown to be effective in mice, but still we have a long way to go before we know if they're truly effective in humans. And there we always need placebo-controlled, double-blind clinical studies.
Which are underway. I mean, there are lots and lots of clinical studies going on. It's just not moving as fast as I think a lot of people would really like it to move. But that's the reality of the space that we're in right now.
Well, it is. And often it is frustrating. And I can speak from personal experience. How long it takes to make a drug can be extremely slow. And we're all getting older. We're not getting, in the case of most of us, we're not getting any younger. And there is a desire to rush into things. But I think we need to exercise some caution here because you can have these negative side effects, particularly in the case of peptides and immune reaction that could be deleterious in the long run.
And in that long run, though, you see these as a very promising avenue for a lot of therapies that are going to help a lot of people, not just with individual conditions, but you think with aging.
Oh, for sure. Not all of these, of course, but those that mimic adversity. MOTS-c is a good example of one that I think has the right signature. I think they have a lot of promise.
Because there is an explosion of research going on sort of at the same time with peptides and this other thing that we're about to talk about, exosomes. I think these happen in the same breath. A lot of times people talk about peptides and exosomes. Both of these are cellular signalers, but exosomes work, well, they are different and they work a little differently.
Well, very different. These are packages of information. They contain, well, they're membrane bound, so they're little vesicles. They're about the size of a virus, so they travel between cells and into cells very easily. And inside, it's not just one message, there's multiple messages. There's peptides inside, there's DNA, there's RNA, even what are called microRNAs, which are similar to peptides, very small pieces, in this case of nucleic acid material, that can go from the brain to other tissues, from tissues back up to the brain. And this is essentially the way the body can coordinate. So if there's an injury on your hand, your brain will know. Or if your brain gets injured, the rest of your body knows. And you need to have these messengers to coordinate the system in the same way you could imagine that the US Post. And so these are little mail deliveries or cargoes that we can both intercept and read. Perhaps we can use these to diagnose diseases, including cancer, but also we can make more of them and infuse them into people to give a false alarm, perhaps even to simulate this adversity and make us live longer.
And before we get to those therapeutic processes, one of the really fast-moving avenues for using exosomes is basically collecting them from the blood, counting them up, and being able to diagnose different injuries. And even like you can pull from people's blood these exosomes, and then you can say like, oh, they have an injury here, or they have a disease there.
Right. Yeah, there are companies now that there's one called Czar Therapeutics. There are others that you can read the cargo and you can say, okay, that comes from the pancreas. That is the signature of a stage 3 pancreatic cancer. So we may be able to use these to diagnose cancer years in advance.
Without biopsying.
Right, just a blood test or even a finger prick at home, send it off and diagnose cancer.
And that would be reason enough to be excited, I think, about the potential for exosomes to tell us what's going on in our bodies. But what else we're learning right now about exosomes is that if we supplement these into the bodies of mice, like by injecting them back into their bloodstreams, it can help with injury.
Yeah, I mean, there's a really well-known paper now from August 2017 by my good colleague down at Albert Einstein College of Medicine, Dongsheng Kai. And his expertise is looking how the hypothalamus, the little organ at the base of the brain, communicates to the rest of the body. And he's found that inflammation and damage to that part of the body affects the rest of the animal, including aging. And in this case, he found, interestingly, that neuronal stem cells, these progenitors in the hypothalamus, they secrete exosomes that tell the body to hunker down and survive. And the mouse can actually live longer if you isolate these exosomes and give it to the mouse. They also did the opposite. They deleted these special cells that make the exosomes, and the mice got diseases of aging and lived shorter.
Why is that happening?
Well, we don't know. In most cases, there's so many things within the exosomes that it's very hard to figure out which of those particular cargoes is responsible for the biological effect. But ultimately, if we can figure that out, we could make exosomes with just that particular component, and that could be a drug in the future.
There was another fairly recent paper on exosomes, a 2019 paper from some Chinese researchers that used exosome replacement to address ulcer healing. And what they concluded was that the exosomes were actually rejuvenating senescent cells. Really fascinating here.
Well, so senescent cells, if you missed the previous episode, are cells that as they get old and they have X differentiation, they lose their ability to read their DNA correctly. They become senescent. They stop dividing. They sit there and they start secreting inflammatory molecules, can even cause cancer to develop. We try to delete these cells. We know that in a mouse and probably in a human, if you get rid of these inflammatory senescent cells, it's good for health. But here we're saying, what the researchers are saying is that these exosomes, the particular type of exosomes, can reverse senescence. That's unheard of. If that turns out to be true, that would be quite a remarkable thing, meaning one day we don't have to kill off these cells, which, in the brain you wouldn't want to do that necessarily. We could actually rejuvenate them and get them to grow again healthily.
Right now, the way we understand how to do that is through the Yamanaka factors. But this would be another avenue toward that same goal of taking X-differentiated cells and sending them back into a differentiated state.
Well, the Yamanaka factor rejuvenation of senescent cells is preliminary. This is some of the work we're doing in my lab. And it's not even clear if the Yamanaka factors are potent enough to reverse senescence. But this finding that you referred to is the first instance that might be possible.
All of this is why there's a lot of excitement around this particular potential therapy. But again, just like peptides, this is sort of the Wild West right now. But people are already taking exosomes and having them shot into their bodies.
They can be delivered by IV or intramuscularly. But again, we don't know what the long-term benefits or side effects are. So we have to be careful. It's still available in some parts of the US, but we don't know.
Yeah, this is not one of those things you have to go to Costa Rica for. At least as of right now, the FDA hasn't cracked down. They haven't said this is a step too far.
That's right. But while exosomes aren't completely banned in the United States, you can bet that the FDA is looking at this for potential safety concerns. And we'll see how things go over the next few years.
And that's not the same thing as saying, like, go do it now.
No, that's not what we're here for. We want to educate and look at what might be available down the line once things are proven to be safe and effective.
And this is another one of those things, like peptides, you're feeling positive that there is going to be actual clinical research that will show us the actual benefits of these. We don't have to make super guesses. We can actually see in the research how exosomes are going to be beneficial and then start to implement them into our longevity regimes in a responsible way.
That's right. And just to be clear, exosomes are a highly validated scientific pursuit. And there are biotech companies, pharmaceutical companies, building giant factories for billions of dollars to make exosomes to treat diseases. The question is, do they work for long-term health and longevity and how safe they are to be used over decades? That we don't know yet.
Okay, let's move then into an area of research that is even further along. Still, we're learning more about every single day, but also has potential anti-aging implications, stem cells.